Hi everyone, let's solve this problem number of islands. Given an m cross n 2D binary grid which represents a map of ones and zeros, ones represent land, zeros represent water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands vertically or horizontally. You may assume all four edges of the grid are all surrounded by water. So let's try to understand it better. So what they're saying is that ones represent land, zeros represent water, and the other thing they are mentioning is that the entire grid is surrounded by water. That is the other thing which they have mentioned. And let's say this is my point r comma c. They said that we can either go vertically or horizontally. So if I am at the top of this, it will be r minus 1 comma c. Towards the bottom it will be r plus 1 comma c. Towards the right it would be r comma c plus 1, and towards the left of it would be r comma c minus 1. So this is the representation of it. Now we have to explore all these paths. We cannot move diagonally, so other possibilities are not allowed here, and we also have to check for the bounds which we have, like if the index is, if this is the 1, r minus 1 and c minus 1 will be not valid, so we just have to check those bounds. Now with all these checks in mind, now let's try to start the debugging part. So I am at 1. So since it's a land, I will also create number of islands. There will be number of islands, right? I'm just using this. Currently it is 0. Then I start here. I will increment my number of islands to 1. Then I'll move to its neighbors. Its neighbors are nothing but these two nodes. So I will traverse through those nodes, and at this particular node I will also check that I might also go through the first node which we have already seen. So to avoid this, we have to mark a node as visited. How are we going to do that? We are going to mark it as visited by changing 1 to 0, so that we don't revisit it. And then now we move to our neighboring nodes. At this particular node we will again mark it as 0, and then this also will be marked as 0, and we will move to its neighboring node. This is the neighboring node, and we will mark it as 0, right? Once this is done, we have found one island which is already marked as 1. Now again we will keep iterating over the nodes. Since we are done with this particular node initially, we will start at this. This is a water, so we will not go ahead. This is a water, this is a water, this is a water, this is a water, 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 and then we found a land, piece of land. Now again we will mark it as land, and we will try to iterate over its neighbors, but both of them are not land, so they are water. We don't really have to do it. And when I'm marking it, I also will change my number of islands to 2. Then again I'll start moving from here. This is water again, so we don't like traverse through it again. This is water, 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 water. Then again we are at the node where it is a piece of land. So again what will we do is we will increment our number of islands and mark it as 0, and now we again move to its neighbors. So 1 is its neighbor. So what we have to do is we have to process that. And what will we do while processing it? We will just mark it as 0 first, because we don't have to revisit it again. So we mark it as 0 and check for its neighbors, and its neighbors are nowhere. They are like not, there is no land. So we are done with the entire processing of the grid. This is how we find our answer. So we are using a backtracking technique here, where we are first at a particular node and we just keep going in deeper with all its neighbors. So all the neighbors are defined by these things, and that's how we are going to process it. Now since you understood this, let's try to code it up. So first we have to get the number of rows. So grid dot length, we will get grid of 0 dot length, and let islands initially will be 0, and we are going to return the islands, and we are going to iterate over every cell. And if it is a land, piece of land, how are we going to check if it is a piece of land? It's by checking if it is equal to 1. If this is the case, we are going to call our DFS with grid rows columns, row comma column. That is all we need. And any which ways we have to increment our islands because we found a piece of land. Now let's write the function for DFS. Grid rows columns, current row, current column. Now we have to check for the bounds. So if it r is less than 0 or c is less than 0 or r is greater than or equal to rows, or column is greater than or equal to cols, or even if it is the water body, that is nothing but r comma c is double equal to 0. Even in this case we will just have to return because we don't have to process it further. Otherwise we have to call DFS. Okay, before even calling the DFS, we have to mark it as visited. How are we going to mark it as visited? We are going to make it as 0, and then we are going to go to the neighboring elements. How are we going to do that? Grid rows columns, then we have r plus 1 comma c, and the same thing we have to do for other 3 neighboring elements, r minus 1, then we have r comma c plus 1, and DFS of r comma c minus 1. This is how it looks like. So now let's try to run it. Let's submit it. It's successful. And now let's also understand the time and space complexity of it. Time complexity is big O of m into n, like rows into columns, because every cell at max we are visiting it once, and we like, so it will be m into n, and the processing here is just big O of one operation, so it would be m into n, and the space complexity here also would be big O of m into n. In the worst case, this would happen when, let's say, I have a let's say I take a 1 1 1 1. So this is the entire grid which we have, and we are starting here. So what would happen in this case is, like, initially it will be at 0 0 and it will be marked as 0, and then on top of it, what are we going to push? We are going to first process, we are going to also process 0 comma 1, and its neighbor will be processed. Its neighbor will be this will be 1 comma 1, it will be 0, and then its neighbor will be processed, which is nothing but 0 comma 1, sorry, 1 comma 0. So all the elements are there in the recursion stack, so it would be at max big of n m into n. So that is the reason it worst case it would be m into n. I hope the solution is clear and you understood this. So if you want to understand recursion backtracking solutions, you can go through the subsets problem. We have discussed how we are implementing it in terms of like concept. Thank you.